see if this works. All right. So then you guys take a sec. You guys are going to follow the process here. Let's find the greatest common factor on number 2. All right, so Abigail, if you're going with the greatest common factor, what would you factor out? A 5 and an x. All these numbers are divisible by 5, and each term has at least one x. No more than that, actually. The greatest common factor is your x. All right, so 5x. Now, if we factor this out, what do I have left then? What do I have left in my parentheses? So Abigail, you got this? So Abigail, how many do I have left in the first term? Just straight up x squared. I already took out the 5. And I took out one of those 3 x's, so I have 2 x's left, x squared. Nice. What about my next term? Super close. I have a single x left because it was x squared. There were 2 of them. I took out one of those x's. The number though, what's 35 divided by 5? Yeah, 7. So I'm going to put a 7x. And you can check and make sure if you multiply this together, you should get back to where you started. So the 5 times 7 is 35. There we go. And then my last term. So Abigail, I'm sticking with you. What is my last term? Yeah, you can divide it. There you go. So when I factor it out, some people say divide it out. That's true. Basically dividing by 5. So what's your 60 divided by 5? 12. 12. And you already took out that single x. There are no more x's left, so just the 12. All right, so this says factor the polynomial completely. We're actually not totally done yet. We took out the greatest common factor, but we still need to figure out what multiplies to be my last number 12 and adds up to be my middle number 7. Can you guys think of, let's just make a list of numbers that multiply to be 12 at all. Yeah, Killian, what'd you get?
3 and 4 can add 7 and times 2.
Oh, the 3 times 4 is 12? You've got lots of options. 2 times 6 is 12. 1 times 12 is 12. These are all the things I can think of that multiply to be 12. But you chose these ones. Why again? Why'd you choose? Oh, because they add up to 7. Okay, so they multiply to be 12 and they add up to 7. Okay, so for that reason, we're going to break this into factors with a positive 3 and a positive 4. Now, I haven't dealt with the whole x part yet. How am I going to break that x into pieces? What do you think, Joshua?
You're talking about the x, right?
Uh-huh, yeah, the x.
It would just be x on both.
An x on both, that's true. Do you know why though?
Because the x within the big parentheses is just x squared.
Yes, exactly. X squared means x times x. So if I were to distribute this, I would get an x times x. I would get an x squared. Nice. And then this 5x has not changed. All right, so now this is totally factored. It is factored completely. Okay, do you guys have questions? All right, I'm gonna give you guys a sec. Try the next one, do the same thing. Start with the GCF, greatest common factor, then factor what's left in the parentheses. All right, you guys at home, please let me know if you have questions. All right, so Joshua K, what'd you start with?
I started out with 2.
With a 2, you factored out a 2, but no x's, just straight up 2?
Yeah.
All right, so what do you have left then?
Well, then I have x squared plus 8x minus 10.
Okay, I didn't write the 8 or the 10 because when I factored out the 2, I should be dividing everything by 2. So I don't have an 8x. What's my coefficient there?
4.
4, nice. My 8 divided by 2 is 4. And you can check this. If you distribute this through, it should get you back to where you started. So yeah, my 2 times 4 would get me back to the 8. And then what's my final constant term there? 5, negative 5. Again, if I distribute this, 2 times negative 5 would be a negative 10. So it would get back to where I started. Nice. Okay. So that was our greatest common factor. All right. So then Thomas H, what do you do after the greatest common factor? Factor it, yep, into 2. So you said smaller, like 2 smaller factors, okay. I still have the 2 out front. What numbers did you go with? Positive 5 and negative 1? All right, so positive 5 times negative 1 is a negative 5, okay. And positive 5 plus a negative 1, or in other words, minus 1, would give us this positive 4. Okay, so that works. And then what else am I missing? The x's, okay. So x at the beginning of each of these. All right, so is that as good as it's gonna get, or can I keep factoring? I see some, no. No, I can't keep factoring. This is my final answer. That is factored completely. All right, so let's look at special factoring patterns. So if they're asking you about like the difference of squares, here's the difference, which by the way, difference means subtraction. Difference of squares, like I've got my a squared and my b squared, I've got them subtracted. That's my difference of squares. If they're talking about the sum of cubes, the sum means addition, and I'm adding things that are cubed. I've got a cubed and a b cubed. It's the sum of them. I'm adding a cubed plus b cubed. So these are our formulas, special formulas. So it says use the difference of squares. Again, difference of, here's my squares. So it's going to be this formula right here. Use the difference of squares formula to factor x squared minus 16. Now, according to this formula, I should have something squared minus something squared. I see an x squared minus, I don't see the 16. It doesn't say 16 squared. Yeah. Is that what you're gonna say as well? Okay, 4 squared is 16. So you're rewriting your 16 as a 4 squared, which that helps me identify the a and the b. The a is the first part that got squared. In this case, it was an x. The b, the second thing that got squared, was a 4. Be careful. I did not put a negative 4 as my b. I put a positive 4 as my b. Okay. So then I'm going to factor into what it says here, an a plus b times an a minus b. My a is an x. My b is a 4, so x plus 4. And then a minus b. A is an x, b is a 4, so x minus 4. Those are my factors. All right. Now, we're going to step it up a notch here. First of all, we're talking about stuff that's cubed. But also, I need like everything to be cubed. Not just the y, This doesn't say 8 cubed and y cubed. It just says the y is cubed. I need to break this down. I need something cubed to get an 8. Okay, I heard a 2. 2 cubed is 8. And I already have the y cubed, so I'm going to say it's a 2y that is all cubed. That's the same thing as 8y cubed. Minus, all right, so I need some 27. I need to have that written as something cubed. So Wilson, what would you choose? I guess you don't really get to choose very much. What would you figure out for your 27 as something cubed? All right, 3. So 3 times 3 is 9, times another 3 is 27. Looks good. 3 cubed is 27. All right, which means my A is the 2y and the B is the 3. So warning, this is what I usually see mistakes on. I see people a lot of times put an 8y as the A value, which is not true. You have to make sure all of it is cubed to find your A. Or same thing for the B, everything for the B has to all be cubed. All right, so then I'm going to use this difference of cubes formula right here. Difference like they are subtracting stuff that's cubed. Let's see. So the 2y, good question. This is where I usually see the mistakes is I had to have something cubed, and it doesn't say, in the original problem, it didn't say 8 cubed. The way they wrote it, what this means is 8 times y cubed. It didn't say that the 8 was cubed, so I had to rewrite it. And we wrote it as like a 2 cubed is 8, and I've got the y cubed, so we put it as a 2y all cubed. All right, Destiny, is that a little better? All right. So I'm going to now put these into my formula. Yep. So I'm going to start with this factor, the a minus b, which we already said a is a 2y, minus the b, which we said was 3, so 2y minus 3. Okay, there's my first factor. My next factor has the a squared. Now, beware, 2y squared is incorrect. I need the entire a. A was a 2y, so I need the entire 2y squared. Okay, I need my a squared, whole thing. And then plus the a times b. My a is a 2y, b is a 3, so 2y times 3. Again, I'm following this formula right here. And then plus b squared. We said b was a 3, so 3 squared. All right, so question, I put in black, I put that you had to have parentheses on this one, but I didn't put any parentheses on the 3. Why does it matter for one of them and it doesn't matter for the other? Yeah, Giovanni, what's your answer there?
Because there's no y in front of it, that square is going straight to the 3.
Oh, the square is, it's just squaring the 3 and there wasn't anything else that needed to be squared? Okay, so I could just leave it like that? So why did I have to have the parentheses on this one then?
You're squaring both of them.
Square both of them, square the 2 and the y. It'd square the entire a, the entire 2y. Okay, nice. So then for simplifying, I will leave the 2y minus 3, but it's like you were saying, I had to square the 2 and the y. So 2 squared is 4, and I have to have the y squared. All right, this middle term, I'm going to simplify this. I've got the constants 2 and 3 I have to multiply together, which is a 6, and then I still have that y, so 6y. And the 3 squared is 9. Okay, so here is my factored form. All right, so let's see. So far I did the difference of squares, the one I had in purple, and I've done the difference of cubes that I had in blue. So you guys take a second. I'm gonna have you guys do the sum of cubes. You're gonna use this one. Okay, for number 6 here, use your sum of cubes. Go ahead and factor it, and then we'll see what you got. All right, so Chase and Allie, I'm gonna reach out to you guys. Take a sec. All right, so Chase, how did you start this?
I took the I factored the 8 down to get 2 cubed, right?
Yeah, nice.
Okay.
So did you say 2 cubed or?
Yeah, 2 cubed times y cubed.
2 cubed, okay, in this case a z cubed, but yeah, a 2 and a z. All right, what about the this other 1? What'd you have to do with the 1?
I didn't know what to do with it. I just left it there.
And 1. Is there anything you can cube to get 1?
Not 1.
1 cubed, yeah, that's true. 1 cubed is the same as 1, so yeah. You can write it like that as far as your a cubed plus b cubed. All right, so then let's label them. So Chase, label what's the a and what's the b?
The 2 would be the a and b would be 1.
All right, I'm missing one thing.
Oh, the z, my bad.
There you go, 2z. A is 2z. You got it. Okay. So then, Allie, I'm going to come over to you. Let's put the a and the b that he found, let's put that into the formula, which I'm using this formula up here. So what should my first factor look like? Oh, wow. Okay, so you got both factors. You've got the 2z plus 1. That was like your a plus b. Okay, and then you have a, in parentheses, 2z squared. Good, you used the parentheses. I'm even going to put those in black like I did last time. You had to have the entire a value. 2z is all squared. And then you had a plus 2z. And then you had a plus 1. All right, so I just want to clarify, if I'm making it look like what I had up here, I think I'm off by a sign, first of all. Let's look at this real quick. A squared minus ab plus b squared. So let's just change the sign. My a squared minus the ab. Now a times b, I think you didn't write times 1. You didn't really need to put times 1, but that's kind of how you get the 2z. It was this a times b, so 2z times 1 is 2z. That's true. And then you had to have your b squared, and you didn't write 1 squared, but that's fine because 1 squared is 1. But that's where that's coming from. All right, there actually is a little bit more simplifying that I can do. The first set of parentheses is still 2z plus 1. And this next set of parentheses, I can actually simplify this down. I've got to square them both. All right, so I have to have the 2 squared, which is 4, and I have to have the z squared. Okay, so other than that, that was as simplified as it was going to get. There's my final answer. Okay, do you guys have any questions? For those of you guys online, you guys have any questions? All right, thanks, Destiny. Thanks, Thomas. Okay, so I'm going to move on. We've got one more. We've got to factor this polynomial. So here's what I'm going to do. I'm going to, first of all, start with the GCF. Greatest common factor. So Samantha, I think you're at home. Samantha, what would my GCF be?
-3.
Oh, that's what I went with as well. So if I factor out the -3, what do I have left?
You would have an x cubed plus -4. I mean -4. There you go.
Okay, and then -4, is that what I heard?
Yeah.
Okay, so now let's check. If I distribute this, does it get me back to where I started? Oh, I think, did you notice that I changed the 12 to a 24?
Oh, no, I didn't.
Oh, that's okay. Yeah, I'm just gonna adjust that to, because I want it to work out a certain way.
Okay.
Let's change it to 24. So I think that changes your 4 here.
Yeah. It would be an 8. -8.
Okay, nice. -8. And again, if I check this, -3 times x cubed is my -3x cubed. Good. And the -3 times -8 is a positive 24. Okay, good. Good way to check. All right, so then now I'm gonna, let's see, Jacob, which formula are you going to use for this? For number 7, yeah. The addition one? The sum? Oh, so you're doing the sum of cubes? You had stuff perfectly cubed and add it up. Here, this is why I put this one on here. It went from having an addition, there was addition at the beginning, but once I factored out that -3, there's now a subtraction in there. So I actually have to do the difference of cubes. So I'm going to write this as x cubed minus, I think you were doing the sum of cubes, so you had to have something cubed. How do you write the 8 as something cubed? Oh, you wrote it as what? Oh, okay. Yep, you gotta factor out the -3 first. So just a reminder, I always do the GCF, the greatest common factor, first. And then I break it into 2 sets of parentheses. Okay, so Jacob, once I got that -3 out, how can I rewrite the 8? It's kind of what we did up here. Nice, a 2. In fact, 2 cubed is what I need. 2 cubed is 8. I have to have something cubed minus something cubed. Because it is a minus, I'm doing the difference of cubes. Okay, so difference of cubes right here. So I'm going to factor it into an a minus b. All right, so a minus b. Again, I'm assuming my a is the x and the b is the 2. There's my a minus b. And then I've got a squared, which again, a is the x, so x squared, plus ab. So multiply those together, I get a 2 times x, plus b squared. My b is a 2, so 2 squared. All right, there's something I'm missing. Oh, the -3, I still need that -3 multiplied in front. So if I simplify this all the way down, I think the best I can do now is 2 squared. I can simplify that down to a 4, but other than that, it is all simplified. There we go. Yeah, Joshua, what's your question?
So we didn't factor, or yeah, we put the -3 on the outside of the parentheses. It couldn't be like factored into an integer, right? When you like cube root it or whatever.
Yeah, I wouldn't do the whole cube root of 24. I always start with the GCF, my greatest common factor, the greatest number or the greatest amount of variables that I can factor out of each of these terms. And they were each divisible by 3. In fact, I took out a -3 to make it a little nicer.
Oh, I see.
Better?
Yeah.
Okay. All right, any other questions? All right, I would suggest if you are making notes, tell yourself what to do in order. First, I do the GCF, greatest common factor. And then second, then I broke down into 2 factors with my formulas. Now, these are special cases. You're not always going to run into these special cases. This is just what we're working on today. But yeah, this is the order that I did pretty much all of them in.